Today we're comparing HSS and carbide cutting tools. Let's start by looking at HSS, high-speed steel, known for its toughness and ability to withstand high temperatures. On the other hand, carbide is incredibly hard and can maintain its sharpness for longer periods. When it comes to cutting hardened steel, carbide tools are generally more efficient. Carbide is great for high-volume production where consistency and precision are crucial. HSS, however, can still be a solid choice for general-purpose cutting tasks. In terms of speed, carbide typically cuts hardened steel faster than HSS. This is due to carbide's hardness and resistance to wear during the cutting process. HSS, on the other hand, may require more frequent sharpening. When it comes to cost, carbide tools are usually more expensive up front but can provide longer tool life. Ultimately, the choice between HSS and carbide depends on your specific cutting needs and budget. Remember to consider factors like cutting speed, tool life, and material being cut. In conclusion, both HSS and carbide have their strengths and choosing the right one depends on your application. So, which one do you think would work best for your next project? Let us know in the comments below. High-speed steel, HSS, and carbide cutting tools represent two fundamentally different approaches to metal cutting, and understanding their differences requires looking at both their material science and their real-world behavior in machining environments. High-speed steel is an alloy typically composed of iron with significant additions of tungsten, molybdenum, chromium, vanadium, and sometimes cobalt. These alloying elements allow HSS to retain hardness at elevated temperatures compared to plain carbon steels, which is why it earned the name high-speed. Carbide, on the other hand, is not a steel at all but a composite material, most commonly tungsten carbide particles bonded together with a cobalt binder. This structure gives carbide its extreme hardness, far beyond HSS, but also introduces a trade-off in toughness and impact resistance that becomes critical in machining decisions. When comparing hardness and heat resistance, carbide is in a completely different class. Carbide tools can maintain cutting edges at temperatures where HSS would begin to soften and lose its edge integrity. This is one of the main reasons carbide enables significantly higher cutting speeds and feed rates. In modern CNC machining, carbide tools are often run at speeds that would instantly destroy HSS tooling. The ability to withstand heat allows carbide tools to maintain sharp cutting edges even under aggressive cutting conditions, especially in materials like stainless steel, hardened steels, titanium, and high-temperature alloys. HSS, while still capable, begins to lose hardness as temperatures rise above roughly 1000 degrees Fahrenheit, about 540 degrees Celsius, which limits how fast it can be run without rapid tool wear or deformation. However, carbide's extreme hardness comes with a trade-off: brittleness. Carbide is significantly less forgiving than HSS when it comes to shock loads, vibration, and interrupted cuts. If a carbide tool is fed incorrectly, encounters a sudden load change, or is used in unstable setups, it can chip or fracture rather than deform gradually. High-speed steel behaves much more ductile in comparison. Instead of chipping, HSS tends to wear gradually or even deform slightly under abuse, which gives the machinist more warning before tool failure. This makes HSS especially valuable in manual machining environments, older equipment with more spindle play, or operations where rigidity is not ideal. In short, HSS sacrifices ultimate hardness for toughness and forgiveness. Cutting speed capability is one of the most noticeable differences in practical use. Carbide tools allow dramatically higher surface speeds and feed rates, which directly translates into higher productivity in production environments. This is why carbide dominates CNC machining, aerospace manufacturing, automotive production, and any high-volume operation where cycle time matters. The ability to cut faster while maintaining tool life means fewer tool changes, faster part completion, and improved efficiency overall. HSS, while slower, performs very well at lower speeds and is often preferred in operations where precision is more important than speed. It excels in drilling, tapping, and milling setups where controlled cutting and operator feedback are more important than maximum throughput. Edge retention and wear resistance further highlight the divide between the two materials. Carbide maintains a sharp cutting edge for much longer periods under proper conditions, especially when cutting abrasive materials or running continuous production cycles. HSS tools wear more quickly in comparison, but they can be easily resharpened multiple times using relatively simple grinding equipment. This resharpening ability makes HSS extremely cost-effective in low-volume shops, repair work, or environments where tooling budgets are limited. Carbide tools, while longer-lasting per edge, are more expensive and typically require specialized grinding equipment if they are to be resharpened at all, which often makes them disposable in many shop environments. In real-world machining applications, the choice between HSS and Carbide often comes down to machine rigidity, material type, and production goals. Carbide is clearly superior in rigid CNC machines performing high-speed cutting in steels, stainless, and exotic alloys, especially when the setup is stable and optimized for performance. It thrives in continuous cuts and high-volume production where consistency and speed are essential. HSS, however, is often the better choice in manual mills, drill presses, or lower rigidity machines where vibration, interrupted cuts, or inconsistent feed rates are common. It is also widely used for short-run jobs, custom fabrication, maintenance work, and situations where tool control and forgiveness matter more than maximum efficiency. Another important distinction is how each material behaves under interrupted cutting and heavy load conditions. Interrupted cuts, such as milling over keyways, holes, or uneven surfaces, introduce shock loads into the cutting edge. HSS handles these conditions far better because it can absorb impact without catastrophic failure. Carbide, while incredibly strong in compression, does not tolerate sudden impact well and can chip at the cutting edge under the same conditions. This is why experienced machinists are careful when selecting Carbide for roughing operations unless the setup is extremely rigid and the parameters are carefully controlled. Ultimately, the decision between high-speed steel and Carbide is not about which material is universally better, but rather which is more appropriate for the job at hand. Carbide represents speed, efficiency, and high-performance machining in controlled environments, while HSS represents versatility, toughness, and reliability in less predictable or lower speed conditions. A well-equipped shop often uses both strategically, leveraging Carbide for production work and HSS for general-purpose machining, setup work, and situations where flexibility and durability are more important than maximum cutting performance.
Thanks for watching. If you're looking for high-quality American-made Carbide Burr tools that are built to cut faster, last longer, and help you get the job done right, visit our website today. We keep our American-made Carbide Burr tools in stock and ready to ship, with same-day shipping available on orders placed before our daily cutoff time. Whether you're working on metal fabrication, porting, welding, automotive projects, or precision grinding, we've got the Carbide Burr you need. Visit our website and order yours today.